house prices with regression analysis. The Boston housing dataset consists of prices of houses in various places in Boston. Alongside with price, the dataset also provides information such as crime, areas of non-retail business in the town, the age of people who own the house, and there are many other attributes that available here. So first of all, import all the libraries to predicting the Boston house price with regressional analysis. Import pandas to handling data frame. Import numpy for numerical calculation, and from sklearn import matrices. It is using for machine learning algorithms. Import matplotlib is used for plot different figures, and import seaborn is also used for plotting. So executing this all the library, now all the libraries are now loaded. Next, importing the Boston housing dataset. So from the sklearn dataset, import load Boston. The Boston is equal to load Boston. So Boston datasets now loaded under Boston variable. So next, initializing the data frame. So using the pandas, that is the pd.dataframe boston.data, initialize into the variable data. Next, adding the feature names to the data frame. Adding, that is the data.columns equal to boston.feature names. The head, data.head, so it contains crime, Jane, Indus, Just, Knox, RM, Age. These all different attributes. So describe the table. So that is the Boston housing price dataset contains 14 attributes. So first attribute is the crime, per capita crime rate by town. JN, that is the proportion of residential land zoned for lots over 25,000 square feet. Indus, proportion of non-retail business areas per town. CHAS, Charles River dummy variable, equal to 1 a tract bounds by the river, 0 otherwise. Knox, nitric oxide concentration, that is the parts per the 10 million. RM is the average number of rooms per dwelling, and age, proportion of the owner occupied units built prior to 1940. DIS, weighted distance to 5 Boston employment centers. RAT, index of accessibility to radial highways. Tax, and many more. So next, adding the target variable to the data frame, that is the price variable. So this is the target variable, and next, check the shape of the data frame, that is the after executing, there are 506 number of rows, contain the 14 columns. So columns header, that is the data.columns, that is the header, that is the 14 header, that means the attributes or field name. Check the missing values. So there are no such missing values. So see row with missing values, there are no such rows. Viewing the data statistics using the describe function. So that means it contains the count, that means the number of records. Mean means the average over the crime. The STD represents the standard deviation, that is the mean represent the minimum value, max represent the maximum value, and 25%, 50% is the median, 25% is the one of the quartile, first quartile, second quartile, and third quartile values. Next, finding out the correlation between the features. Finding out the correlation between the features, that is the shape of the correlation matrix. It 14 by 14. Obviously, there are 14 attributes. So, plotting the heat map between these correlations and these features. So, wait, yes, it's drawing. So, after this visualization, we can easily say that is the crime is very much related with, that is the 3, 3, 6 to 8, 9. Ninth column name is red tax, etc. So this is the heat map among all the correlations. So splitting the target variable and the independent variable. So x is equal to data dot drop. Data dot drop is except the price column, all are assigned to the variable x as a target variable, and as an independent variable, and y is the target variable, that is obviously data price. Splitting the training and testing data as per 30% as a test data, and training data is the 70%. So the function is train test split. So x is the independent variables value, y is the target value, test size is the 30%, and the random state is 4. Next to try to find out the prediction using the linear regression, training the model first. So import the library linear regression from scikit-learn and create the linear regressor, that is the LM is equal to linear regression. Next, train the model using the training set, lim.field training and y testing data set. After the fitting, the intercepting value is 36.35 and the other coefficient values are this. So obviously that is the y equal to mixi plus intercept value is this, and I is vary from 0 to 12. And next is the model evaluation. Model prediction on trained data, that is the y prediction, that is the lm.predict over the training data set. So after model evaluation, the R square value is 0.74, adjusted R square is 0.73, mean absolute error is 3.08, mean square error is 19 point something, and root mean square is 4 point something. So R square, it is the measure of the linear relationship between x and y, that means the between the independent variable and the dependent variable, and that is predict from the independent variable. Adjusted R square is the adjusted R square compare the explanatory power of regression model that contains different numbers of predictors. Mean absolute error value is measure the difference between the two continuous variables, here actual and the predicted values of y. Mean square error, the mean square error is the just like the MAE, but square the difference before summing them all instead of the using the absolute value. And the last one is the root mean square error. Root mean square error is just like a MAE. Next, visualizing the difference between the actual prices and predicted value. Predicted value, so is very straightforward. That is the very good predicted value with the prices are very much associated. Next, checking the residuals. There is no pattern visible in the plot and the values are distributed equally around 0. And checking the normality of the errors. So here the residuals are normally distributed, so normality assumption is satisfied. Next, check for the test data. That is the predicting test data with the model, and the matrices, it is very much same as, that is the R square, adjusted R square is very much same as the test data. So here the model evaluation scores are almost matching with that of train data, so the model is not overfitting. Thank you.